Hey, it's Dr. Asatar Bear, and this video is about utility theory. Right, utility theory is one of the foundations uh, of demand and the demand curve. It's based on one simple idea about human nature. Okay, so human nature, what is this as a concept, right? This means the thing that every human being ever has in common with every other human being ever, right? Human beings can be different, but they have something that all human beings share, right? Characteristic that they all share. Okay, and this idea is that people seek to maximize their happiness and minimize any pain or discomfort. Right? So the technical word that's used instead of happiness, all of these are like synonymous though, right? Like happiness, satisfaction, pleasure, pleasure, joy. All of these meanings are encapsulated in the term utility. All right, so utility is a idea that as a philosophical movement, it's part of this branch called utilitarianism, or utilitarian philosophy. Uh, Utilitarian philosophy is really developed by James Mill and his son John Stuart, and a family friend, Jeremy Bentham. These are the and of these three, probably the best known is John Stuart Mill. Um, so these are the philosophers who developed the idea that the best society is one which maximizes the utility for all in that society. All right, so this rests on a foundation itself of that an individual is doing this, right? So, and that's where microeconomic theory really takes both of these ideas and incorporates it, okay? Which is not surprising because both James Mill and John Stuart Mill also contributed to economic theory in addition to philosophy. Uh, all right, so human nature is to maximize happiness or utility and minimize pain or discomfort. Let's take this and restate this idea. Okay, so maximize utility. We will put this in terms of its mathematical formulation. All right, we will call it max U. Okay, so we will use the symbol U to stand for utility. And so when we say maximize, we mean that in the mathematical sense, right? That is, if there is a function, we want to determine its absolute maximum level. Okay, and the human beings are doing this always subject to the constraints that they face, right? That is a summary of human nature. Maximize utility subject to constraints. Now, what about the other part of this that we talked about, the pain and discomfort? Well, that is actually in here already, okay? The pain, discomfort, anything you dislike, anything that annoys you. Uh, this is simply the negative uh, of utility, okay? So in technical terms, this is called disutility. All right, disutility. So we're trying to avoid anything which subtracts utility and seeking out anything that adds utility. And in that way, we obtain the maximum utility that we can given our constraints. Okay? Now remember, microeconomic theory, everything is put in terms of mathematical expressions. So naturally, there's a mathematical expression which gives all of this, right? Which conveys all this. And this is called the utility function. Right? The utility function is a mathematical formula, mathematical function that tells how much utility an individual gets, right, from different things. Now, every individual is different, okay? So, however, we're trying to talk about what does everyone have in common, right? That's the topic here, human nature. So, though we cannot say without reference to a particular individual, this is their specific utility function, but we can say what's the general nature of this thing. Okay, so and it's like this, all right? Utility is a mathematical function of the following. Okay, so Q1, Q2, Q3, etc., all the way up until Qn. All right, so what is this, right? Remember, U stands for utility, happiness. Q1 stands for the quantity of good 1, right? Q2 stands for the quantity of good 2. Q3 stands for the quantity of good 3, all the way up until however many goods there are. Okay, so N equals the total number of different goods, and what the hell, we can add in services, that are in the economy. All right, so there can be a bunch of them. Now, for our purposes, just for simplicity, we're going to focus mostly on just 2 goods, but that doesn't really change the nature of the reasoning, okay? The utility function can have up to n goods, okay? So remember, this is the general form of the utility function, okay? So general form just means all we've done is we've said, here's the independent variables, and here's the dependent variable, okay? So the utility, that's the dependent variable, the happiness, satisfaction, pleasure, joy, etc., and good 1, good 2, good 3, etc., however many goods there are, these are the independent variables, okay? So a lot of people have looked at this and said, all right, so what we're basically saying here is that goods and services, these are the inputs to happiness. Happiness is the output, right? So people have looked at this and said, that sounds a lot like materialism, does it not? I mean, the idea that having more goods, that's what's going to make you happier. A lot of the philosophers and a lot of the great religious figures and sages and whatever have really disagreed with that throughout time, right? And have said that's not what gives rise to human happiness. But nonetheless, right? We're talking about microeconomic theory. Microeconomic theory says it is the quantity of these goods which gives you utility. Okay, and there's another thing too, which is leisure, but we're going to talk about that later when we talk about labor markets. Okay, so the next step is to look at how does this work? What is an example that we can do which gives us an understanding of how utility functions? Okay, so having more of a good gives you more utility, but the relationship might not be totally linear. Okay, so, and in fact, the theory tells us it's not at all linear, right? So let's say that this happens, okay? So remember, this is our utility function, all right? Utility is a function of quantity of good 1, quantity of good 2, good 3, etc., right? Let's say that we hold constant every variable in this expression except for 1, okay? So the utility as a function of all these quantities, except all of them are held constant except for 1, right? And then we can see, well, as you get more of just this one good, how does your utility change? Okay? And the idea is it doesn't change in a linear fashion. It changes in a nonlinear fashion. Okay, so let's do it like this. Okay, let's say that we're taking in more of the quantity of some good, and along the way, that also gives us more utility. Okay, so we've got the quantity of a good. Okay, let's just in our example. Okay, let's say that the quantity of this good Q1 refers to number of glasses of water. Right? Let's say that you are lost in the desert and you're really thirsty, right? Really thirsty. So we'll start at 0. Okay, you got no glasses of water, and you're upset about that, right? You got nothing else either. Okay, so we're keeping constant all these other variables at 0. Okay, so no water, no happiness. You're just on that. You're about to die from thirst. Okay, and let's say that you see off in the distance, but there's waves of heat distortion, but you can see, okay, there's a table there, and there's a person there, and they've got a pitcher of water, and they pour a cup of it. You approach, and would you like a glass of water? You're like, yes, I would. That's the thing I'd most like, right? So you go from 0 glasses of water to 1 glass of water, and your utility, let's say, just really shoots up. All right, goes from 0 to 400. That's like that glass of water. It's the best thing you've ever tasted. It keeps you from dying. All right. Right? A person says, "Would you like another glass of water?" Well, yes, I would. I'm still thirsty. I was very, very dehydrated. I would like another glass of water. So, and this one is pretty good. I mean, it's still, among the best glasses of water you ever had. It's not quite as good as the first one, though, truth be told, right? I mean, the first one was absolutely delicious. But the second one, you're not as thirsty. You got to admit, right? Your stomach has shrunk by being wandering the desert and whatever. So let's say that this causes your utility to rise now to 500. Okay, you're a lot happier than you were before. And then the person says, would you like a third one? I mean, we have a whole pitcher of water here. And let's say that this one raises your total utility to 550. Okay, and then the fourth one to 560. Right. The fifth one, well, at this point, like, do you want another glass? Well, you're kind of on the fence now, right? I mean, if you ever drank 4 glasses of water, one after the other, your stomach can only hold so much, right? So, if you were to drink this one, you're really on the fence about it. Let's say that means when you're on the fence, it means it's not really adding anything to your utility, right? If it's not adding anything, then your utility is staying the same, okay? So, and then would you like a 6th glass of water? Oh, no, I couldn't do it. I can't do it. 6 glass of water, that's just too much. I can't. My stomach will start to hurt if I do that. And so, well, that's you wouldn't voluntarily do that, right? Because we've assumed a person maximizes utility. But if someone dared you, let's say, or I don't know, they held a gun to your head, drink the water, drink the 6th glass. Well, all right, I'm drinking it, but I'm not real happy about it. Let's say it has brought my utility back down to 540. Because, yeah, I've got more water, but, I'm not happy about that situation, right? So your utility goes up, but not in a linear fashion, right? Not the same amount with every successive glass of water. Okay, so if we were to graph this relationship, we would have something like this. Okay, so let's say that this is our total utility on the vertical axis here, and down here our total number of cups of water. All right, so 0, 1, 2, 3, 4, 5, and 6. All right, so glasses of water. All right, and let's say our scale is like this: 100, 200, 300, 400, 500, 600. All right, so if we go ahead and graph this, where we've got something like this happening, right? 0 and 0, 1 and 400, 2 and 500, 3 and 550, 4 and 560, staying constant, 560, and then going down to 540. All right, so we connect these dots and look at what's happening here. Okay, so what we've produced here is a graph of the utility function. Okay, so graph of total utility as a function of the quantity of 1, right? Because all of the other variables are held constant, right? So again, utility, a function of Q1, Q2, Q3, etc., all the way up to Qn. But all these are constant, so it's just a function of a quantity of good 1. All right, so look at this. It shoots up, but then it starts to kind of level off, right? Utility it's not linear with respect, and it could even go down, right? You get sick of things, right? You get sick of things. So we have a way to describe this getting sick of things, right? As you have more. But now tomorrow, that's a different story, right? Tomorrow you're going to be thirsty again. So we're talking about within a kind of the same general span of time, right? Within that day, okay? So as Q1 increases, holding everything constant, the utility increases up to a point. Right? But not at the same rate. Okay? The rate of change of the utility function is a special term. Okay? That term is called MU. Right? MU stands for marginal utility. All right, we'll define that marginal utility as the change in total utility relative to the change in one of the goods. Okay, so this is the marginal utility. I put a little 1 there. The marginal utility of good 1. Okay, so the change in total utility relative to the change in good 1. All right, so we're making it easy for ourselves here because good 1 is changing by only 1 each time. Okay, so if we say what is in this column, what is mu, that is delta u over delta q1, right? So we're going from 0 to 1, right? Going from 0 to 1, the change in the total utility, 0 to 400. So we got 400 on top, 1 on the bottom. So this is just 400, right? Because we go from 0 to 1, okay? So there's 1 on the bottom each time. We can just sort of leave that off, right? We can just look at how much is this changing. So this one's 100, 50, 10, 0, and negative 20. All right. So now let's draw another graph here directly below. And this one will be a graph of same horizontal axis, okay, number of glasses of water. We'll try and line these up, 1, 2, 3, 4, 5, 6, like that. And on this one, marginal utility, okay? So 100, 200, 300, and 400. All right? So now what we're going to see here is the point. This graph looks rather different, right? Because one glass, 400, right? The second one, 100. The third one, 50. Then 10. Then 0. Then negative 20. We connect these and we've got this downward sloping curve. Okay, so this is a graph of the marginal utility of good 1. That is the change in utility relative to the change in quantity of good 1. All right, for those of you guys who have taken calculus, this is actually not really a delta, right? It's the partial derivative of the utility function with respect to just one variable, okay, the quantity of good 1. All right, so we're just using a delta just to kind of keep it simpler. We don't require calculus for this course. So if you know what those symbols are, that's fine. If not, that's okay as well. All right. So we have here a graph of total utility, and then we have a graph of marginal utility. All right. Marginal is marginal utility. The whole concept of the margin, very, very important concept in microeconomic theory. In fact, microeconomic theory, when it developed historically, it was called the marginalist revolution. So the early neoclassical microeconomists were called marginalists back in the day, back in the 19th century. Okay, so we get from this the idea, it's called the law of diminishing marginal utility. Right, we're just generalizing a little bit from the example that we did with the cups of water in the desert and whatever. So, what we saw was as the quantity of good one increased, what happened is that the marginal utility decreased, right? So, for a while, the total utility increased, right? It increased for a while, then it leveled off, and then it actually started to decrease, right? So this brings us to, this is the two concepts that we've already described, right? Utility and disutility. It is possible to consume too much of something, and then it stops giving you pleasure and starts giving you pain, right? That's totally possible for everything. Anything is the difference between, as they say, medicine and poison is the dose, right? So, can you drink too much water and harm yourself with that? Yes, absolutely, right? So, stay hydrated, but don't go crazy. All right, so law of diminishing marginal utility, and this is a general idea in microeconomic theory. We would say this holds for all things, all goods, all services, all right, everything. There's a law of diminishing marginal utility. Okay, so here's the problem with all this. I've been avoiding it so far, but maybe you've already noticed it, right? The problem is, what do we mean? What is utility? I mean, we've described it, right? I've said it's happiness and whatever, but I've also put a number on it. So the problem is, what does this number mean, right? How do you measure it? How do you measure utility? And the immediate and obvious problem that occurs is that utility is not observable. It's not observable. I mean, we have it as a concept, right? Like we have other things or concepts, love and hate and, I don't know, whatever, all kinds of human emotions. We feel these things. We believe they exist, but where is it? Show me. Like if somebody was, ooh, utility. This sounds fascinating. Could you please show me utility? We'd be like, well, okay, a little bit of a problem, awkward. No, we actually can't show you utility because it's not observable. Okay. This has always been the problem with the theory of utility, with the theory of marginal utility, all kind. This has always been the problem with utility theory. Utility is simply not observable. So what the marginalists tried to do, what the early utility theorists tried to do, is they tried to get around this problem. Okay. Now notice, this is not a problem with other things, right? Like if we want to study temperature or velocity, distance, things like this, right? These are measurable things. We can say, well, what is the velocity of something? Well, okay, it's the distance over time, right? It's we have a clear, unambiguous measure for that. We don't have that with utility. Okay, so the utility theorists set out to solve this. Okay, and one influential person in this is a guy named Edgeworth. Right, Edgeworth, and followed up by an Italian economist named Pareto. Okay, so Edgeworth particularly, right, tried to, again, put all of this into mathematical form and also deal with this very difficult question, which is we're saying we're maximizing something, but what is the unit of utility, right? What is the unit? An initial way that they dealt with is they made up a unit. Okay, they made up a unit of measure for utility. Okay, and that made up unit of measure was called the util. Right. I think that's funny because util is just, it's a funny word. Oodles of utils. The util, the util. But of course, making up a unit of measure doesn't really help. It doesn't solve the problem, right? The problem is you can't observe it. So you can call it whatever you want, right? I mean, I can call it blah blah de bloob or whatever. Like that doesn't solve the problem. The problem is, what is this? There's no actual unit of measure that makes actual sense, right? Um, so Edgeworth and following that Pareto try to get around this, okay? And what they said was, look, okay, we can't observe utility, but we can observe people's choices, right? We can observe people's choices. Like, okay, people have two things, okay? They got A versus B, all right? You say, hey, choose one of these, all right? We're not going to either one. We're not even going to introduce prices to the question. We're just going to say choose A or choose B, all right? So let's say that a person chooses A. Well, okay, well, why did you choose A? Well, I don't know. I prefer it. I prefer A to B. Okay, well, that we can observe, right? And we can infer from that, right? We can observe that, and we can infer that the reason that they chose A to B is because the marginal utility that they got from A is greater than the marginal utility that they would have gotten from B, right? So we're still using utility theory. We're still using in the background the idea that people are going to maximize their utility. ST stands for subject to their constraints. That's still our central idea. And we're even using the concept of marginal utility, but it's now all in the background, right? We're saying, well, we don't know the exact number. Like we can't say like, okay, well, this one is 15 and this one's 11. We don't know that that's the case, right? We don't know. All we know is that it's greater, right? Marginal utility of A must be greater than the marginal utility of B, okay? So this is how the early neoclassicals, early utility theorists proceeded in terms of their reasoning, okay? So they said, look, if we're doing this, right, if we're talking about what we can observe choices, and then we can assume that it's based on what they prefer, okay? This gave rise to something called preference theory, okay? So preference theory is not different from utility theory. It's a way of getting at the same question, right? The question is, okay, we have this theory that says everyone, human nature, is to maximize utility subject to the constraints, but we also have a problem, right? We can't really measure utility, okay? So preference theory was a workaround. It was an attempt to get around that issue, all right? So we're going to introduce some specialized terms for this, okay, just to help us make sense of this preference theory, okay? We said, look, let's get a little more, let's fine tune our notion of human nature and say, we assume that all human beings, okay, they maximize utility, like we said, right? And these four assumptions are met, right? These assumptions are called being rational, right? The assumptions of rationality, right? And rationality assumes the following, okay? So four things. The first one is called complete preferences. Complete preferences. Okay, so we can, let me introduce some of the terminology, okay? So A is preferred to B, okay? That statement, right? And what we mean is by a particular individual, okay? Preferences are, of course, always unique to one person, right? We don't, another person might share them, but we're we're not saying everyone has the same preferences. Far from it, right? We have different preferences. We just want a symbolic language, okay? So we're going to do it like this. We're going to say A and then this P, okay, with a circle around it. And that stands for A is preferred to B, right? So saying that the person has complete preferences, it just means, look, only one of the following can be true, okay? Only one can be true, but one is always true, okay? So either A is preferred to B, or B is preferred to A, or the final situation is that you're indifferent between the two, okay? So A is preferred to B, B is preferred to A, and the following A and B individual is indifferent between the two of them, okay? So the I with the circle around it means indifferent between A and B, all right? So only one of these is true for any comparison, right? Any choice, A versus B. Okay, it could be good, service, whatever it is, right? Do go this way versus that way. You know, you're going to prefer one of them or you're going to be indifferent, okay? And we can say that for every single situation, okay? A person has complete preferences. It's like saying the person knows themselves. Okay, number two. Number two is to say that these preferences are transitive. Okay, transitive preferences. Transitive preferences means that your preferences are logical or consistent. Okay, logical or consistent. It means that your preferences obey the transitive property of mathematics, basically like this, right? If it is the case that the individual prefers A to B, and it's also the case that the individual prefers B to C, then it must be the case, right? It must follow that A is preferred to C, okay? That is the transitive property. So this is just, to avoid absurd things from happening, right? Like if you're in a store and you pick up some carrots and you're like, I like carrots. Oh, this is great. I'm going to buy these. And then you pick up some bananas and you're like, I like bananas even better. Okay, I'm going to switch. I'm going to get these instead. And then you pick up apples and you're like, no, I like apples the best above all three of these. I'm going to get the apples instead. And then you were to see the carrots and be like, oh, carrots. Oh, okay, I'm going to get those. Oh, no, I like bananas. I like apples. I like carrots. I like that. You would never leave the store, right? You would perish in the store because you couldn't make a decision. That's a violation of what I'm talking about right there. Transitive preferences means, no, it's, you can form a logical and consistent ranking of preferences, okay? You can have a ranking, right? Like this person, right? It would be A is on top, then B, then C, right? That ranking makes sense. Now you can change your mind. We're not saying you have to, you can change your mind. Okay, then you have a new ranking, right? And that new ranking would be transitive. It would be consistent within that, okay? The third one is called non-satiation, right? Non-satiation basically just says, look, it's always possible to get more utility. Utility itself never ends, right? Utility never ends. So, and more utility would always be preferred to less utility, okay? So, we put it this way, right? More utility, so that's one choice, preferred to some amount less. All right. And then finally, the last assumption that we consider as part of this collection of things that together means rationality, it is the law of diminishing marginal utility, like I mentioned before, okay? So law of diminishing marginal utility is often called the assumption of concavity, or sometimes the assumption of convexity. We'll get to this shortly, right? Sometimes this is just a technical term here. Okay, it means the shape of the indifference curve is convex toward the origin. So, this is all right. So we already went through what is the law of diminishing marginal utility. So if these four assumptions hold, then it is possible for us to go a little bit further with preferences, right? To construct an entire theory based around these ideas. We will start by taking two goods that an individual likes. All right, two goods that an individual likes. Let's say these goods are, we'll call them Q1 and Q2, okay? And let's say that Q1 is the number of pieces of popcorn, all right? And Q2 is the number of pieces of candy. Okay, you're at the movies and you, of course, you like to eat popcorn, you like to eat candy, and you like both of these things, okay? So what utility theory does is utility theory takes us to a whole nother level, right? We're like, oh, do you like popcorn? Yeah, I like popcorn. You like candy? Yeah, I like candy. Okay, great. Well, that's about as much as we can say about it. But what we're doing here is we're trying to get like super clear on that, right? How much exactly do you like popcorn and candy? Let's try to measure that, okay? And how could we possibly measure it? Well, we would measure it based on what you're willing to give up versus what you're willing to gain, okay? So let's say we compare two different situations, all right? So here's our situation, okay? We've got situation A, in which the individual has like 30 of the popcorn and 10 of the candy, versus situation B, where the situation is reversed, right? They've got 10 of the popcorn and 30 of the candy, okay? And then we say, well, how do you feel about these? And tell us the truth, okay? No lying to us. There's nothing at stake here. Would you prefer to have A, 30 popcorn and 10 candy? Or would you prefer to have B, 10 and 30? Okay? It's up to you, right? You whatever you like. If you want A, okay, you get the A. If you want B, you get B. Or maybe you're on the fence about it. You're indifferent, right? Let's say that we've figured it out so that we've said, okay, what is the individual? This individual is indifferent between these 2 points. Okay, so now let's make a graph of this, right? And we're going to put Q1 on the horizontal axis and Q2 on the vertical axis, right? Popcorn and candy, okay? So we've got this kind of thing going on, right? The number of pieces looks like this, okay? 10, 20, 30, right? And what we've said is we've got 2 points here, okay? We've got point A right here, right? And we've got point B right here, okay? And right, 30, comma, 10 at A, and 10, comma, 30 for point B, okay? So if this is the case, right, if the individual sees these 2 points as equivalent, they're fine with having either one, right? Well, that tells us something important, right? We infer from that what that means is, look, the marginal utility that you get from having one versus having the other is the same, right? The marginal utility is the same. So you could give up A, and as long as you get B, then indifference means you wouldn't be happier, you wouldn't be less happy, you'd be the same level of happiness, okay? So marginal utility of A equals the marginal utility of B, okay? That is the meaning of indifference, right? Indifference means, I could go either way, okay? So if we go with this a little bit more, right? We say, all right, what would it take, okay, what would it take to trade me B for A, right? You give up A and you gain B. What happens? Well, A, here's your situation, right? If you go from A to B, just putting in these dotted lines here. So if that is, you're doing this A to B, okay? So you're going to reduce the number of pieces of popcorn you have. In other words, you are going to have a loss here, okay? We could say in general terms that is delta Q1, right? Representing in this situation a loss. And on this axis, you're going to have a gain, okay? So the gain, the delta Q2, okay? You've got a loss versus a gain, all right? And what we've said is if we say, well, what makes this equal to the person, right? What you're going to give up, okay, that negative change in Q2, how is that made equal to the individual, right? The negative change in Q1, what makes it equal to the positive change in Q2, okay? And we're saying it is the marginal utilities of these two, okay? So the loss in the marginal utility of having that additional popcorn. Oh, I have less popcorn. I only have 10 pieces of popcorn. 10 pieces of popcorn to get through the whole movie? Oh my God, I had to give up 20 of them. That's bad. It made me less happy, right? So that's a loss, right? It's causing you a loss in happiness. But look what you got in exchange for it. You got extra candy, right? You got 20 pieces of candy in this case, right? Because you went from 10 to 30. So that compensated for you, right? Now here's the thing, right? We can observe the delta Q2 and the delta Q1. You know what I'm saying? We can observe that because that's in terms of something that we can see, right? That's pieces of popcorn. This is what this is, right? Number of pieces of popcorn. We can observe the pieces of popcorn. Over here we got candy. We can see the candy, okay? Nobody's telling, well, what's candy? Right? That's not the question, right? The thing that we can't see is the marginal utilities. So we're going from what we can't see to what we can see, all right? And if we rearrange this equation, right, we divide both sides by mu2 like this, right? This one drops out. We divide both sides by negative delta Q1, all right? Actually just by Q1. Leave the negative sign over here. Okay, so we end up with delta Q2 over delta Q1 equals mu1 over mu2. Okay, so notice delta Q2 over delta Q1, this is the formula for the slope of something, right? And mu1 over mu2, we're saying, okay, well, this is equal, right? And this concept is called the marginal rate of substitution. Marginal rate of substitution. All right. Technically, it'd be the marginal rate of substitution between goods 1 and good 2. Okay, so marginal rate of substitution, or MRS, 1, 1, 2. Okay, so between good 1 and good 2. So what we're getting from this, right, we're saying, all right, here's what we've got, right? We've got 2 points the individual is indifferent between. And we have the person's willingness to give up one of them, to substitute one of them, to gain for another one. Okay, so what the marginal rate of substitution is the individual's willingness to give up good 1 in order to gain good 2. Okay, so now let's fill in all of the points on this curve, and let's say that we've got a curve, a set of points, between which all of these points, like A and B, the individual is indifferent between. Okay, and this is an individual's indifference curve. for these two goods. Okay, so for good 1 and good 2. All right, individuals indifference curve for good 1 and good 2. All right, that's my lecture for today. Thank you very much.